5.2, verifying trig identities. So for 5.2, I really recommend that you work through these examples and you try problems as well as the homework problems with at least one other person. So I strongly recommend that you work with a partner or in a small group of maybe 3 or 4 so that you can help each other in terms of working through the steps. It'll also make it more fun and you'll be able to remember it long term as well. So again, I strongly recommend that you get into small groups and work through the example, you try, and homework problems together. So when you verify an identity, you cannot assume that the two sides of the equation are equal because you're trying to verify or prove that they are equal. So here's the important part. When you are verifying identities, right, either side must be worked on separately. So work on the left-hand side on its own, right-hand side on its own, or just one side at a time. But you cannot cross-multiply, add the same number to each side. You can't balance the equation. You have to keep them separate because you cannot assume that they are equal since you're trying to prove exactly that. Okay, here's an example. Verify the identity, meaning prove that this is indeed true, that the left-hand side is equal to the right-hand side. So we did this back in chapter 4, and then we did some in 5.1 when we're simplifying expressions. So it's kind of a similar thing here. So I'm going to work on the left-hand side because it looks like there's a lot more that I can do here on the left-hand side. So one way that I can do this is I can separate this into two separate fractions. So if I separate, I get secant squared x over secant squared x minus 1 over secant squared x. Again, I'm just working on the left-hand side right now. Okay, and secant squared x over secant squared x gives me 1. 1 over secant squared x gives me cosine squared x. And if you recall from the Pythagorean identity, 1 minus cosine squared is equal to sine squared x. So I have proven through simplifying the steps on the left-hand side that the left-hand side is indeed equal to sine squared x. So again, I just make this side, simplify, replace it through a series of steps, and then you're going to make it look like the right-hand side. Okay, go ahead and try this problem. Verify the identity. So here is one way to go about it. Sine squared x plus cosine squared x is equal to 1. And then I have 1 over cosine squared x over secant squared x. Well, 1 over cosine squared x can be rewritten as secant squared x. And I still have 1 over secant squared x. And these cancel out, giving you 1. All right, let's take a look at another example. Verify the identity, meaning prove that this is indeed true. So I'm going to go ahead and work on the right-hand side because I see that on the right-hand side I have two fractions. Maybe I can put them together. So to add these, I'm going to need a common denominator. So my common denominator will be 1 minus sine of x times 1 plus sine of x, multiplied by a form of 1. All right, 1 plus sine of x. Here multiplied by 1 minus sine of x over 1 minus sine of x. And so in the numerator, I get 1 plus sine of x plus 1 minus sine of x. So notice that in the numerator, the sine of x's cancel out, so I get 2 over 1 minus sine of x times 1 plus sine of x. But if I multiply the denominator, I have a conjugate there, so I end up with 1 minus sine squared x when I FOIL, because the middle terms are going to cancel out. Now let's take a look at the following. The denominator 1 minus sine squared x is equal to cosine squared x, so I can replace that. And then, remember, 2 over cosine squared x, that's the same thing as 2 times 1 over cosine squared x. So that cosine squared x in the denominator here, that can become secant squared x. So 2 secant squared x. Notice that I have made the left-hand side and the right-hand side equal to each other. Again, what you're doing is you're taking one side and then replacing it with equivalent expressions. They just in different forms. And then you make it look like the other side. Okay, you go ahead and try this problem. Verify the identity. If I were working on this problem, I would work on the left-hand side. I'm going to combine those two fractions together. Okay, so I get a common denominator of 1 minus cosine of x times 1 plus cosine of x multiplied by a form of 1. When I add straight across, I get 1 plus cosine of x plus 1 minus cosine of x, and I'm able to cancel out the cosine of x's. In the numerator, I get 2. In the denominator, I get 1 minus cosine squared x. 1 minus cosine squared x can be replaced with sine squared x, and since the sine squared x is in the denominator, that's like 1 over sine squared x, that can be replaced as 2 times cosecant squared x, and I have matched the left-hand side and right-hand side. So your credit is going to be in the steps, in the correct steps that you show. Okay, let's take a look at the last example here, verify the identity. So let's go ahead and I'm just going to pick a side. I'm going to go ahead and work on the left-hand side here. I see cotangent squared x. I'm going to replace that with I caught a fish, right? So I caught a fish. So I can replace that with cosecant squared x minus 1. So cosecant squared x minus 1. And then I notice that the numerator, it's a difference of 2 squares, so I can factor that out, right? Cosecant of x plus 1 times cosecant of x minus 1, because it's a conjugate, right? So if I were to FOIL this out, right, the middle terms would cancel out and you would end up with cosecant squared x minus 1. And the whole thing is over 1 plus cosecant x. But notice that 1 plus cosecant of x, right, these two factors, these two binomials, I can cancel them out. And I end up with cosecant of x minus 1. Okay, now I can go further here on the left-hand side, replacing cosecant of x as 1 over sine of x minus 1, combining the like terms, writing as a single fraction, and that would make it look like the right-hand side. Or you can also work on the right-hand side separately. Again, the key word is working on it separately. So I'm always keeping the left-hand side and the right-hand side separate from each other, but you are allowed to work on one side at a time and then have them match. So on the right-hand side, you might notice that I have 1 minus sine of x over sine of x. I'm going to separate that as 2 separate fractions. So I get 1 over sine of x minus sine of x over sine of x. And 1 over sine of x is cosecant of x. This is just 1. So notice that the left-hand side and the right-hand side match. Okay, again, as long as you keep the left-hand side and the right-hand side separate, you are allowed to do that. And they, the last step to match each other. It's going to depend on what you find is like a path to take, right? So if you see that here, oh, I can separate these into 2 fractions, let's see what I can do. You might, kind of do that here a little bit and then do something to the left-hand side and see if you can get them to match. It's going to depend on what you see as an available option. Okay, go ahead and try this problem. Secant of x plus tangent of x equals cosine of x over 1 minus sine of x. So I notice that on the left-hand side, I can replace secant of x and tangent of x with 1 over cosine of x and sine of x over cosine of x. Then I see that these are 2 separate fractions with a common denominator, so it can combine as a single fraction. And then at this point, you could do other things like multiplying by the conjugate. So I could multiply by 1 minus sine of x in the numerator and the denominator. So I can rationalize the numerator there. But I might think, maybe I'll just work on something on the right-hand side. It's up to you. Okay, so I decided to multiply by a form of 1 on the right-hand side. I'm going to multiply by the conjugate 1 plus sine of x over 1 plus sine of x and simplify that through. Again, if you had chosen to, on this left-hand side, you could have multiplied by the conjugate of the numerator, multiplying by 1 minus sine of x over 1 minus sine of x and simplifying that out. It's your choice, as long as you keep the left-hand side and right-hand side separate. In the denominator here, I end up with 1 minus sine squared x. In the numerator, I've just kept them as factored form. And notice that 1 minus sine squared x can be replaced with cosine squared x. And then notice that everything's in factor form. One of the cosine of x's cancel out. So you end up with 1 plus sine of x all over cosine of x. And ta-da! The left-hand side and right-hand side match. So with these problems, you're going to just try to ask yourself, like, what can I do? Can I replace with a different identity? Can I add? Can I separate the fractions? Can I multiply by conjugates in the form of 1? Can I factor? Can I FOIL? These are all the questions that you want to ask yourself, and just do what you can. And then it'll lead you to verifying the left-hand side and the right-hand side. Now, when you work on your homework, I highly recommend that you work with a partner or in a small group so that you can talk with each other and kind of bounce ideas off of each other that will really help you go through the steps and also help you to remember how to do these types of problems better.